Okay, next situation is if we know the slope and we know a point that's on the line. Again, this is a case where we want to use point slope form. So make a note of that on the front flap for me, please. Okay, this is going to be a little bit easier than the last one because we already have our slope. So remember, we want to write our equation in this form, y minus y1 equals m times x minus x1. We already know the slope is 2 though, so this is going to make our job a lot easier. So I'm going to go ahead and plug in values. y1 is going to be the y-coordinate of this ordered pair, which is 3. x1 is going to be the x-coordinate, which is 2. Okay, so now all I need to do is simplify. This is going to say y minus 3 equals 2x minus 4. And then I need to add 3 to both sides to get y by itself. So when I add 3 to both sides, I'm going to get y equals 2x minus 1. And then to graph that, I'm going to plot a point at -1, and my slope is 2, so that means I'm going to go up 2 over 1, up 2 over 1, and connect your points. Okay, and that's the graph of that line. Our next situation is using a word problem. Okay, let's say you're given the problem, and this is a little bit weird, I guess. They didn't actually tell you what to do, but we're going to write an equation to represent the situation. It says to work out at a gym, Sam pays a registration fee of $50 and $75 per month. We want to write an equation. Notice how we've been using x and y as our variables so far. Let's go ahead and continue that pattern. So over here on the right side, I'm going to define my variables. Let's say that x represents the number of months that he goes to the gym, and y represents the total cost that he pays. You guys can probably figure out what this equation should look like, but we're going to say that the total cost is equal to, notice how he's paying $75 per month. Anytime you're talking about an amount per a certain time period, that's a clue that that number is your slope. So we're going to write this in slope-intercept form. And we're going to say $75 represents our slope. He's paying $75 for every month that he goes to that gym. But he's also paying a one-time registration fee of $50. So the $50 represents your slope-intercept. Your y-intercept. So this is what our equation would look like to represent the total cost. All right, our last two situations have to do with parallel and perpendicular lines. We talked about this quite a bit in geometry last year. If we want to write the equation of a line that is parallel to another one, remember that parallel lines have equal slopes, and go ahead and make a note of that. Let's go ahead and first graph the line that they gave us, y equals -1x plus 3. On my graph, I'm going to put a point on 3, my y-intercept, and then I'm going to figure out where the next point is by going down 1 and over 1. Okay, so there's the line that they gave us, but we want to write the equation for a line that's parallel to this one, but it has a y-intercept of -4 instead of 3. Since parallel lines have equal slopes, they have the same measure of steepness, when we write our equation, we're going to use the same slope. Theirs was -1, ours is also going to be -1, but they said that our y-intercept is going to be -4. So the equation of our line is y equals -1x minus 4, and if we graph that, you're going to see that it does appear to be parallel to the line they gave us. So I'm going to plot my y-intercept at -4, and that has a slope of -1, so I'm going to go down 1 over 1 and connect those points. Okay, and you can see that the lines do appear to be parallel to each other. let's talk about perpendicular lines really quickly. We also talked about perpendicular lines last year in geometry. And remember that perpendicular lines have opposite reciprocal slopes. I'm going to abbreviate here. If you remember from geometry last year, this is the symbol for perpendicular. So we're going to say perpendicular lines have opposite reciprocal slopes. Okay, they gave us the equation of a line y equals negative 2x plus 1. I'm going to go ahead and graph that down to over 1. So there's the line they gave us. We're going to write the equation for a line that's perpendicular to this one, meaning it intersects this line at a 90-degree angle. So we know it's probably going to look something like this. It's going to have a slope, a positive slope, but I don't know exactly what it's going to look like without writing out the equation. Okay, we know that the slope of this line is negative 2. That means that the slope of our line is going to be the opposite reciprocal of negative 2. So for our line, the slope is going to be positive 1/2. The reciprocal of 2 is 1/2. And when we say opposite reciprocal, we also mean to change the sign of the slope. So this was negative, this one's going to be positive. And the way that you can check if these are opposite reciprocals is if the two numbers multiply to give you negative 1. If you multiply negative 2 times 1/2, you do get negative 1. So those are opposite reciprocals. And then it said that our line is going to have the same y-intercept. So our b value is also going to be 1. So I can plug those numbers into my slope-intercept form. So I'm going to get y equals 1/2 x plus 1. That's the equation of our line, and it should appear to be perpendicular to the line they gave us. So let's go ahead and graph that. Our y-intercept is in the same place, but this time our slope is 1/2, so I'm going to go up 1 and over 2. And I'm going to go ahead and connect those points. Let's see here. And it's not completely perfect. That's because I'm doing it by hand, and I think the squares on here are not actually squares. They look a little skewed, but this should be a 90-degree angle right here. So those are two perpendicular lines. Just the most important thing is to remember that perpendicular lines have opposite reciprocal slopes, parallel lines have equal slopes.